Welcome all. Okay, this one we need to do. Total present value of whole life assurance taken by a life age 50, where the basic sum assured is 100,000, and the sum assured increases by this at the start of each year, excluding the first. The benefits are payable at the end of each year of death. Okay, there is a derivation for this, small derivation. It will take 5 minutes time. It's like this. Suppose you need something like this. Consider benefit increasing from time to time. Normally, we said if this guy dies here, then one will be paid here. We're talking about one guy. If this guy dies here, pay one here. If this guy dies here, pay one here. If this guy dies here, pay one here. So I'm not talking about many payments. I'm talking about one payment, but the time of the payment is not fixed. That's why in the diagram I have to write all this. It depends where this guy will die. If this guy dies here, pay here. That way. Only one payment, okay? This is not an annuity. I'm saying or, because we don't know when this guy will die. Now instead of paying 111, we can increase it. The benefit we can increase. How we can increase the benefit? We will say, if you die during the first year, at the end of the year, we'll pay one. However, if you die here, we'll increase your money. What way will increase your money? It could be compound increase or simple increase. It is like this. If you die during the second year, we'll give you 1 plus b square, 1 plus b power 3, that way. In that case, if this is the time interval when this person will die, kx to kx plus 1 we take. If the person dies here, money will be paid here. Anyone who can say what amount will be paid here? This will be 1 plus b power. See, this is important, right? Here 3 means 3 comes here. 2 means 2 comes here. So this one will come here.
Power kx, sir.
Yeah, 1 is here, right? So power kx. And what is the present value? What is the present value here?
1 plus b power kx into v power kx plus 1.
Yes, whatever is the amount, that is not 1. Suppose this is 10, that means this is 1 plus b power 10, this amount, okay? If b is 0.10, 1.10 power 10. So that amount we need to find the present value. And it will be v power kx plus 1, whatever you do. This is present value. If you find expected present value, expected value of this, but here we have only kx, so you can multiply and divide it by 1 plus b, so that it will become kx plus 1, and this is a constant, we can take it out. And there is no notation here. 1 upon 1 plus b you can write, and this one is 1 plus b power k plus 1, and v is also here. I included both this one and this one. Here power, it's like, suppose 5 power 6, I've written 5 power 7 by 5, and there was 8 power 6, 8 power 7, and 8 power 7. So it's 5 into 8 power 7 divided by 5, separate. That way I've written v 1 plus b. These are the two factors. Kx, I wrote 6 here. You can compare that way. Now, what will happen? Here, this v into 1 plus b, suppose this is another v. Another type of v kx plus 1. Again, we got this form. Whenever you see v power kx plus 1, you have to close your eyes. And I mean, I've seen many, they close their eyes and they write. You should close your eyes and write this way, x. But when you open your eyes, make it sure the interest rate is no more the interest rate is no more I. Because here v is a link with I. Now, forcibly we have taken this v, for this I should be from this equation. And v and this b, there is a link, okay? this we took for this new v is 1 upon 1 plus I. If you find I here, you can find the reciprocal of this, that will be 1 plus I by 1 plus b. And if you find I here, you have to subtract 1. So I will be, if you subtract 1 here, it will be I minus b by 1 plus b. Okay, so at the interest I, where I is I minus b by 1 plus b, remember, you have to do this way. And this is a simple formula. Let's go to the question now. Basic sum assured given. Sum assured increases by this at the start of each year excluding the first year. That means this way. Excluding the first year means what? That means here it will be 1, but after that it will increase by b, compound increase. Okay, sum assured increases by this percent at the start of each year excluding the first. Here b is given. B is given 1.01923%. Okay, sorry, no percent I've written, or 1 point this percent. B is given, and summation is given. See the answer, so easy. The answer should be according to the age. Go to the formula. 1 upon 1 plus b ax I have to write. 1 upon 1 plus b ax. That's all. Nothing more. What is x here? So the age is 50 here. So it's 1 upon 1 b a50. That's all. The interest rate is capital I here. A50 you have to evaluate at I. What is I? I minus b by 1 plus b. I is given 6%. Okay. Minus b. B is this, whatever, by 1 plus b. And you need not calculate this. You have to remember, because in the table they've given only 4% and 6%. They write b such a way. You see this in 50 problems or more than that. They write b in such a way that capital I will come to 4% finally. So you need not, if you see this one 1.92 and 6%, you need not calculate. Directly you can write at 4%, you need to find. So that will be 1 upon 1 plus b. B you write here. And A50 at 4% you need to calculate. That's all. Derivation is not required. You see A50 at 4%. Derivation for understanding. This is the sum assured. Okay. This is sum assured 1, but we have a sum assured that you need to multiply. That's all. This is your b, 1 plus b. This is the formula. Up to this much we derived. You can go back and you can check. This is the sum assured. For sum assured 1, we derived this. And this is the answer. It's simple. Now, okay, this looks a bit complicated, but it's not like that. But for that, we need a small derivation. Let's go back and continue from here. Now, instead of compound increasing like b every time, b square 1 plus b power 3, if you have simple increase, then how can you find? That will do. If you have simple increase, when I say, it's like this. You have simple increase. Suppose these are the points. And let me write this 0, 1, 2, 3, 4. This way. Here the benefit is 1. The benefit is 2 here, 3 here, 4 here, that way. So if you consider kx2 kx plus 1, if the person dies here, fit and find here, you check here, 4 comes here. Okay, so the benefit will be kx plus 1, k plus 1. Just write x here. You find the present value here. Okay, so PV is kx plus 1 into v power kx plus 1. Previously, this was 1 only, because the benefit was 1 here. So 1 into v power kx plus 1 we wrote, but now it's a bit different. Then expected present value. Here we have a notation as well. Increasing annuity. So we write this notation. And summation, this random variable, you have to make it small k plus 1, v power k plus 1, probability kx is equal to k. We have to write this way. Will not worry, because these things are calculated, k default qx or whatever notation you use. This is calculated, and This you will get from the table. Okay, this is in the table. So this you get from the table. Now this is for the whole life assurance. Okay, you get, suppose, IA 30. This means actually someone is 30 now, presently 30, and he got a sum assured of 1 if he dies during the first year. If he dies during first year, 1 will be paid. If he dies during second year, 2 will be paid. That way. This is the promise by the company. And for that, the outgo for the company will be this. Instead of A30, we have to write IA30. A30 present value, if the sum assured 1, wherever he dies, we started with this one, then that is A30. Here, increasing annuity means IA30. And for the term, we write this way. If this is 10-year term, we write this way. If there is a term 10 year, you have to write this way. For increasing also. Increasing also, it's not that every time you will get whole life. There is a formula for term assurance that you need to remember. There is a small derivation as well, but derivations are not important. You need to do the problems. Problems will come in the exam. Okay, so remember, IAX is for whole life and constant increase, not compound increase. And this is for term, and we have a formula. The formula for this one, again, you need to remember. You will use many times. Even within the exam, you will use 10 times, 10 to 15 times this formula. This will be IAX. There is small derivation. We'll do that maybe whenever required. PX and VN. Then you will have, can you remember this? I'm not sure, something like this. Okay. Yeah, maybe I can derive. It will take 2 minutes time. Okay, let's check this, if this is true or not. Derivation is not difficult. This is the formula. Let's try to derive if this is correct or not. Then we'll apply this formula. Okay, let's apply. No, we have to check. Yeah, we can check here as well. Go to this question. What you need? You need age here, term here 25. Okay. What more you need? Yes, n I forgot. Okay, n I have to write here. Okay, let me write n here. N. Just a minute. N here. Yeah, this problem you can solve. Okay, you do it yourself. If you have any problem, you can ask me. I'll explain you how to do this. Here, D is used. You need to remember that. Px and Vn you can replace, and select mortality. Bracket is here. Why bracket is here? Because given select mortality. But more than the solution here, that anyway you will be able to do. It's not a difficult one. You need to understand equation of value. Okay. Separately, you can write premium and maturity benefit, death benefit. Two are there because this is endowment. Separately, you have to find maturity benefit is easy. It doesn't matter. It's a constant um, promise or it's a variable promise to the policyholders. Remember, this is we used to write A X N1 here. We don't write any such thing, but this kind of a thing here is the same. P X and V N, that is the formula. Consider that the person survives. You have to know the final benefit. You multiply with finite benefit. This and this are same. This is your maturity benefit. Okay. Now let's spend 5 minutes for the question more than anything else. That is important here. So what it says, a man age 40 buys a special 25-year endowment policy If the policyholder dies before age 65, then all premiums paid so far are returned without interest at the end of the year of death. Level premiums are payable annually in advance for 25 years or until earlier death. Calculate the annual premium. Assuming something, okay? So this means what? When they say this means what? A man aged exactly 40 buys 25-year endowment policy that pays 30,000 on maturity. If the policyholder dies before age 65, dice means not 65, anytime. Okay, let me write 40 here, and starting from 40, suppose this guy dies here. This is a question to you. This is 40 to 41. If you want to write time 0 to 1, that means that way it will be 5. Suppose this guy dies here. What is the sum assured here? They've not given sum assured directly. What they said, 30,000, that is the maturity benefit. I already found the present value, expected present value maturity benefit here. You see this one. Now I'm talking about the term benefit. Okay, term benefit is this one. For this one, we have to apply the formula I showed you, and then this is your outgo for the company, and income for the company is this. You know this already. Select mortality, if you know, you will be able to do that. So everything is over. The only thing is you need to understand why this is the death benefit. Okay, this is the maturity benefit, this is the term death benefit. Why this? That I want to explain. See, according to the question, they have not given the sum assured here. Here sum assured is, they say you must have paid premium P here. If you die, your sum assured will be that P. That's all. After the end of the year. Suppose you will not die here, you will die during the second year. You must have paid two premiums and you died here. So the two premiums they will collect, they will pay 2P. Whatever you have paid already, that amount will be returned. That's all. Whatever amount you paid, that will be returned. Suppose someone dies here after 10 years here, and he must have paid some premiums. What will be the sum assured? 11P. Because 0 to 10, they are 11P. P, he must have paid yearly once. The whole amount will be returned here. That is the sum assured. All premiums paid so far are returned without interest at the end of the year of death. So now if you consider this one, this is a new type of a problem. Okay. Suppose you write kx here, kx plus 1 here, and the person dies here. How many are there? You calculate premiums. P. How many p's are there here? Kx plus 1 p's, right? So don't you think it will be p into kx plus 1? That will be that will be the benefit. And what is the present value of the benefit? Present value will be p into kx plus 1. And expected present value will be p extra. That's all. We used to write kx plus 1. Now p came. Okay, we already found that you can take expected present value of kx plus 1. That was ix. And if there is a term, it's ix1. Now p extra came. That's all. So you have to write p1p here. This one. This is one time problem. Don't worry. These kind of problems are not many, like 10. You have to practice. This is one time problem. You need to understand this problem. This is only one problem in CM2 part, CM1 part 2. So you go through that. Okay. And that is linked with this one. I'm saying you once again. If you go to the derivation, this one here, you see for kx plus 1, the present value is ix. If you have p into this, okay, here p, here 2p, because if the person dies here, he must have paid twice premium. Okay, so 2p will be returned, 3p will be returned here, 4p will be returned here, p into k plus 1 will be returned here. So instead of paying 1 at the end of first year, 2 at the end of second year, 3 at the end of third year, 4 at the end of 4 year, they will say somewhere so that you will get this. Whatever way they explain, you can go through that. Then p extra comes. So here p will come extra. Here for term p will come extra. That's all. P you multiply here, you will get the answer. And if it's select mortality, where you need to put a bracket, that you have to know. Okay, that's all. Only thing remains is the derivation of the formula. Derivation of this formula. I'll do it next time. Okay, let's not extend. Go through this one and complete properly. Class is over for today. Anything you need to ask before I leave? All right then. Thank you.
Thank you, sir.
Okay.